Well, we're in section 7-2, and this is going to be our part 2 for 7-2. So we're going to start with problem number 14. And we're going to have x double prime plus 2x plus 4y is equal to 0. And we're going to have y double prime plus x plus 2y is equal to 0. And we're going to have initial conditions. X at 0 is equal to y at 0 is equal to 0. X prime at 0 is equal to y prime at 0 is equal to minus 1. Now, the cool thing about this particular problem is it's going to take the entire whiteboard, and I don't have an entire whiteboard. I only have what I can see here. And so that's just the name of the tune, and we're going to have to go with it. Okay, so that being the case, we want to take the Laplace transform of both of them. Okay, so that's what we're going to do. And we're going to end up with s squared x of s plus 1, because I've got a minus 1 sitting there, plus 2 x of s plus 4 y of s is equal to 0. And I'm going to have s squared y of s plus 1 plus x of x, that's that guy there, plus 2 y of s is equal to 0. Okay, so I got those guys, and now I'm going to line them up in an equation, so it looks like I have two equations, two unknowns. Okay, so I'm going to have s squared plus 2 x of s plus 4 y of s is equal to minus 1. And then I'm going to have x of s plus s squared plus 2 y of s is equal to minus 1. So now it looks like I have two equations, two unknowns. Those are my coefficients sitting there in front of the x of s's and my y's of s's. I'm going to use Kramer's rule and say x of s is going to equal minus 1 4 s squared plus 2 divided by s squared plus 2 1 4 s squared plus 2. Okay, so when I get done, I got minus s squared minus 2 plus 4 minus s squared plus 2. And here I've got s squared plus 2, s squared plus 2, minus 4. Well, the minus 4 is going to take out those 2 times 2 that are there. And I'm going to have, well, I think I'm going to keep the minus 4 there. I think I'm going to call it s squared plus 2, the quantity squared, minus 4. Because if I look at my Laplace transform table, that might be helpful. Then I'm going to look at y of s. What is y of s going to be? Well, I'm going to have s squared plus 2, 1, and I'm going to have minus 1, minus 1. And on the bottom, I'm going to have s squared plus 2, the quantity squared, minus 4. And I'm going to have minus s squared minus 1 on top, and s squared plus 2, the quantity squared minus 4 on the bottom. Now, if I haven't done anything wrong yet, everything would be fine. So we'll attack the x of s guy first. We'll solve him first. Not sure why. Okay, so x of s is minus s squared plus 2 over s squared plus 2 squared minus 4 minus s squared plus 2. We're just going to do some algebra. S to the 4th plus 4s squared plus 4 minus 4 minus s squared plus 2 divided by s squared plus 4. Okay, that seems good. Now we're going to do a partial fraction and say that this is a over s plus b over s squared plus cs plus d over s squared plus 4. Okay, that seems like a reasonable thing to do. I want to put it all under one denominator again. And when I do that, I'm going to have as cubed plus 4 as plus bs squared plus 4b plus cs cubed plus ds squared. And now I'm under s squared plus 4 again. And I look at what I had on top of it, minus s squared plus 2. Okay, so now I'm looking at how big this guy is. Okay, he's not that big. Okay, that's good. We'll continue. All right, so we're going to look at the s cubed term. In the s cubed term, I have an a and I have a c. So a plus c is 0. I'm going to look at the s squared term. And I have b plus d is minus 1. Then I'm going to look at the s term. And the s term 4a is 0. And then I'm going to look at the unit term, and there's only one of them, 4b is 2. Okay, well, if 4b is 2, then obviously b has to be 1/2. And if 4a is 0, then a has to be 0. And if a is 0, then that sort of means c is also 0. If b is 1/2, then that implies d is going to have to be minus 3 over 2. Okay, so we all agree with that? And when we get done, we end up with x of s is equal to 1/2 over s squared, because that's the b guy, plus minus 3 over 2. Is that the d guy? That's the d guy, divided by s squared plus 4. And you look at those guys and we say, this guy here looks like probably number 8, and this guy looks like number 5. And we say, okay, we'll rearrange stuff so it looks a little better. S of c, 1/2, 1 over s squared, minus 3 over 2, s squared plus 4. I need a 2 up there, so if I have a 2 up there, I'm going to have to put a 4 down here so that I can have a 2 up there. Okay, and then we run it through our Laplace transforms, number 5 and number 8, and we kind of find, and we do an inverse Laplace transform on everything I see. X of t is equal to t over 2 minus 3/4 quarters sine 2t. Okay, so that looks good. Now we still have to find y of t. Okay, so we'll go back and find where our y is. That's not there, so go up to here and find where y is hiding out. There is my y. So we'll grab the y. Grab y, copy, and put it in the next place and say paste. Okay, so we do the same type of thing, and we see that y of s is going to be equal to minus s squared minus 1 divided by s to the 4th plus 4s squared, and then the 4 minus 4, they go away, so this is going to be minus s squared minus 1 divided by s squared plus 4. Okay, s squared over s squared plus 4. Okay, so that looks good. We're going to do partial fractions. So I'm going to say I want a over s plus b over s squared plus cs plus d over s squared plus 4. Now minus s minus 1, s to the 4th, 4s squared on the bottom. Okay, I combine these guys and I get, what am I going to get? I'm going to get a s cubed plus as plus 4as. As cubed plus 4as. Okay, and the next guy is going to be plus bs squared plus 4b, and the next guy is going to be cs cubed plus ds squared, all over s squared plus 4. Okay, so now I look at that and I say, well, the s cubed term, a plus c, is equal to 0. The s squared term, 4, no, not 4, s squared term, b plus d is minus 1. I look at the s term, 4a, and that's all there is equal to 0. I look at the unit term, 4b is equal to minus 1. Okay, well, assuming that I did that right, this implies that a is equal to 0, and if a is 0, then that implies c is equal to 0. And this sort of implies b is equal to minus 1 over 4. So if b is minus 1 over 4, then d has to be minus 3 over 4. Okay, so that being the case, y of s has to be minus 1 over 4s squared, because the b guy was the s squared term, minus 3 over 4 s squared plus 4. Okay, I'm going to use the same guys again. This guy's number 8, this guy's number 5. Do an inverse Laplace transform, both sides of the equation. Y of t is equal to minus 1/4 t The minus 3/4 come out. I need a 2 up there. This is going to be minus 3 over 8 sine 2t. I hope I didn't leave out too many steps there. Okay, so we've solved for x of t and we solved for y of t. Now what we're going to do is going to check our work. Okay, so x of t is equal to t over 2 minus 3 over 4. Do a sine 2t. I look at x of 0, and I see x of 0 is 0, which is supposed to check. And I look at x prime at t, and I get 1/2. The derivative of minus sine is going to be minus cosine. Minus 3/2 cosine 2t. I look at x prime at 0, and I see that that's going to be minus 1. Check. So that's good. I'm going to need an x double prime at t. X double prime at t is going to be 3 sine 2t. The derivative of minus cosine is going to be sine. Okay, so that's good. Now we got to check the y guy. So we said that y of t was minus t over 4 minus 3 over 8 sine 2t. And y at 0 is supposed to be 0, and it is. Check. Okay, and then we want y prime of t. That's going to be minus 1/4. The derivative of minus sine is minus cosine. Minus 3 over 4 cosine 2t. Y prime at 0 is supposed to be minus 1. Check, it is. You use the green guy. Check, it is. And then we're going to need a y double prime at t is equal to the derivative of minus cosine is going to be sine, so it'd be 3/2 sine 2t. Okay, well, going back to the original problem, someplace we have the original problem, who knows? The original problem said that x double prime plus 2x plus 4y is going to be 0. Okay, so x double prime, 3 sine 2t, 3 sine 2t plus 2 times x. 2 times x. T over 2 minus 3/4 sine. T over 2 minus 3/4 sine 2t plus 2y. 2y minus 4 over t minus 4 over t minus 3/8 sine 2t has to be 0. Okay, so I've got a t and I've got a minus a half. How come that's not 0? What am I doing wrong? Okay, so back to the original problem. I have 2 of these guys. I have 4 of these guys. That's my problem. I would check the right problem, I might have a prayer. Okay, so I've got t minus t. They go away. Boom, boom. I've got minus 3/2 sine, and I've got another minus 3/2 sine. What am I doing wrong there? How come they're both minus 3/2 sines? How come? Minus 3/2 sine, minus 3/2 sine. Oh, yeah, that's good, because minus 3/2 minus another 3/2 makes minus 3 sines, and I got a 3 out there, so no problemo. Check. Okay, I'm almost done. Now I've got to check the y double prime guy. Y double prime plus x plus 2y has to be 0. All right, so y double prime 3/2 sine 2t plus x, which is t/2 minus 3/4 sine 2t plus 2y minus t/4 plus minus 3/8 sine 2t has to be 0. Now, how did I get those guys? Well, they're sitting right there. That's how I got them. I didn't have to go and looking for them. Okay, so I got t/2 minus t/2. That guy goes away. I got minus 3/4 minus another 3/4, which would be 3/4 and 3/4. That'd be 3/2. I got plus 3/2. These guys go away. Boom, boom, boom. And I have 0 is equal to 0. Check. So that ends problem number 14. Isn't that lovely? That is just so marvy. I told you it would take a little more than one piece of paper. And expect something like that on your tests, so that would be okay too. All right, so go to something easy. Number 18. F of s is 3s plus 5. All right, well, we'll do a partial fraction. A over s plus b over s plus 5. And we get that 3 is going to be as plus 5a plus bs. And we look at the s term, and we see that a plus b has to be 0. And we look at the unit term, and we see 5a has to be 3, implying that a is 3/5, which put that into this guy here, and that implies b has to be minus 3/5. And we have that f of s is equal to 3/5s minus 3/5 s plus 5, and we're using, what are we using? Number 4 and number 7, and we end up taking the inverse Laplace transform of everything, and we end up with f of t is equal to 3/5 minus 3/5 e to the minus 5t. Now, again, and we'll just check it in the back of book. So check back of book. So that guy checks, so he's okay. 22. f of s is 1 over s squared minus 9. Okay, so we'll do a partial fraction and say f of s is going to be a over s plus bs plus c over s squared minus 9. Okay, we have, from that I can get that 1 has to be a s squared minus 9a plus bs squared plus cs. And I look at the s squared term, and I have a plus b is 0. I look at the s term, and I have c is 0. And I look at the unit term, and I find that minus 9a is 1, implying that a has to be minus 1 over 9. And if a is minus 1 over 9, then b had best be 1 over 9. So I got f of s is equal to minus 1 over 9 over s plus 1 over 9s over s squared minus 9. I see that this falls in the category number 4, and that this is the hyperbolic cosine one that I really don't have any numbers on, but I remember that that's the case. I take the inverse Laplace transform of everything I see, and I see that f of t is equal to minus 1 over 9 minus 1 over plus 1 over 9 hyperbolic cosine of 3t. And this guy checks with backup book. And we're done with section 7.2.